and a little bit different. We're going to be collecting the positive and transmitting it over to the LED in this example. But what we're going to do is build a toggle switch. Okay, so I'm going to break down everything it's doing for you, and then we're going to go to schematic view, and then we'll rebuild the whole thing. Okay, this is a very complex circuit, but it does answer a lot of questions when it comes down to transistors working with Mofsets. So once you got done with the last Mofset example, which was a slow burn switch, then you can jump onto this one. So that's the prerequisite to this. So instead of the negative, we're going to be hooking up the positive. Oops. And here is the gate, drain, and source. The source is going to be positive. Okay, it's going to go out the drain and into an LED. And so we would need to run the LED to a negative, okay, and it's automatically on. Okay, so it's on because it's a P channel Mofset. Okay, so what I'm going to do is I'm going to just take a 1000K resistor. I'm going to run it the gate over to here. So you can see that it's hooked up to the gate, the first pin. And I do want to leave one gap. Alright, so just need like a neutral wire color just to illustrate this, maybe white. Alright, so if I take a negative charge and hook it up to this resistor, it stays on. Okay, no charge. If I take and run it to a positive, it turns off. Okay? Now you notice when it turns on and I go like this, it stays on because it's switched on. So that's different than a transistor. A transistor has to always be hooked up to ground in order for it to be on. Okay? This one doesn't. It's on by nature. And look at that. After I go to the positive, it turns off. On. Off. So because of that, and did you see what just happened? So off. Now I am ground. So I can turn it on too. But I can't turn it off. Not unless I have maybe a static shock or something like that. So I could definitely turn it on, but I can't turn it off. So negative keeps it on, positive turns it off, but it does not need to be always hooked up in order to be in that state. Okay, so knowing that I can have it on and off without it being always hooked up to a positive or negative means that I can use it as a toggle. And what makes it stable is if you think about it, what can make it stable is this capacitor. So this capacitor is hooked up to the negative channel. Okay. If I run this to positive, it turns off. Okay. Stays off. What about if I go like this? Nope. Okay, let's turn it on. What about this? Nope. So that capacitor is making the circuit stable. Because it's holding a charge in here, so therefore I can't ground it out. Alright, so now we know how to make it stable, so it doesn't like go on for no reason. That should have been a circuit in all itself right here, probably. You should probably practice this one and really understand what just happened there. Okay? Almost want to explain it again. So, right now the circuit's on. Okay? I can't turn it off because I don't possess positive energy. I do. Okay, so now I'll turn it off. But because my body is grounded, I can turn it on. So it's not stable. Okay? So when you introduce a capacitor to it, I can turn it on, and I can't turn it off because I don't have positive energy. I can turn it off, but I can't turn it on because the capacitor has made it stable. Alright, now let's go on to the next part of it where we now add a transistor to it and understand what that looks like. Okay, so this next part we're going to be taking the tail end off here, and we're going to be introducing a transistor. Okay, so I need a 222 or a 3904. Let's see. Slippery little buggers. Good, a 3904. Okay, again, because we have been away from transistors for a little bit. Okay. We got emitter, base, collector. Emitter, base, collector. So I'm going to put the emitter down here. And I'm going to take and hook the emitter up to a negative. And I'm going to hook the collector I'm going to just kind of like put some space there, and I'm going to hook that up to 100K hooked up to the negative or positive. Okay, so it kind of looks like that. I guess I could have just ran. Yeah, let's just tidy that up a little bit. I don't need this, it's just confusing. And I'll move this up one, and I'll hook. There we go. So the collector in this case has got a 100K ohm resistor hooked up to the collector. The emitter is got a negative hooked up to it. And I'm going to hook up the collector up to the gate. Okay, so nothing's really happened there, right? So we're going to hook a wire up to the transistor. Okay, sweet. It turned on. Alright, it stayed on, and you can see it's flickering as I touch this wire. See it flicker? So it's not stable. It's not stable. Okay, what happens if I go positive? Turns off for a second. Short circuits too, bad. Negative, okay, turns off but then turns back on. So now it doesn't have that feature anymore where if I go one, it goes to the other, it goes the other way, because this is being hooked up both at a negative and a positive, though the positive is a lot weaker. So this is a direct to the negative, but this one has 100,000 100K resistor hooked up to it. Sweet. So I no longer can toggle it back and forth. What would make it stable? What about a capacitor? Okay. Now if I hook up either way, it works. So I can hook up the positive to the negative on that, or I can put the positive into the negative channel, and then that one keeps it off. So that's a way of making it super stable in both directions. So by running the capacitor to the negative to the positive, it keeps it off. And then if I have the positive to the negative, it keeps it on. And it's a stable thing. I can't interrupt the transistor anymore with my groundedness. See? Good. So, what do we do now? Well, we could hook another transistor to it. So let's go on to do that and see what that looks like. Alright, so now that we have this circuit, kind of explained how the capacitor works to make everything stable. Okay, I'm going to take that capacitor out. Okay, remember, the gate is not stable. Okay, that's where we left it. Alright, so now we want another transistor. We're essentially hooking up the same scenario that we had with the touch capacitive circuit. So this is a mix between the touch capacitive circuit and the Mofset slow burn circuit, in the fact that the collectors are feeding the Mofset gate. Okay, so right now we have a stage 1 where we have one transistor feeding them the Mofset's gate. We want a second one, and we want one on either side of the switch. Okay, that's the deal. And that will make it so it toggles on and off. So we're going to start utilizing this switch now. So let's start slow, and that way we know what's going on. So let's just introduce the switch. I'm going to take a 100K resistor and run it to the switch. And then run the other one to the drain. Okay. Okay. Now it's hooked up to the drain of this. So this one's in control of it being sort of positive. What's this one going to do? We'll see. Alright, so now we are also going to run the gate over to that switch. Oh, it turned on. Pretty cool. Okay, before we hook up another transistor, let's play around with our capacitor again. Okay? Alright, sweet. First we'll do a static wire. So let's say on the other side of the switch is going to be a negative. What's going to happen to our scenario? It's going to turn it off. And it's going to stay off. Look at that. Sort of. It's kind of flaky. Oh, now it's on. Now it's off. But it's not stable. See? It's like, so it's closer. It's closer to what we want. What it needs is a little bit more sensitivity. So that's what the transistor's for. So we're going to put a transistor over here. It's going to be tight squeeze. And we're going to feed its emitter negative. We're going to feed its collector a capacitor with the negative in the rail and the positive into the collector. We're going to take a 100K ohm, making that 3 100K ohms down the circuit. And we're going to put that in the positive. And run that into the collector too. So if you look real close, they're all running into this switch. So we have a 100K resistor running into the positive. We have our negative running into the emitter. And what's hooked up to that gate? Can we guess? Well, this time, instead of the touch capacitor being hooked up from emitter to gate, it's going to be gate to gate. Gate to gate. So this gate is going to be hooked up to this gate over here via wire. Just like that. Oop, gate. Alright, so can we deduce what's going to go on? Remember this capacitor, making it stable. We could take the capacitor out just to see what happens. Nothing. Toggle off, toggle on. off, toggle on. So that capacitor now runs the show. It's to the point where it's been amplified enough times where we can use it to keep it as a stable source to keep our switch on. So right now, what it's doing, if you think about it, this is the positive, and this is the negative. Okay, it's the best way I can describe it. Okay, this is the negative. You notice this one's negative also, but it's toggling between these two. So right now, it's sending a negative. Oops. It is kind of, it's not sensitive, it's just, the thing I don't like about this breadboard is it feels loose for some circuits. I think it's these wires. Oh, there he goes. Oops. See, everything's kind of like loose. There we go. So, okay, right now, sending a negative. Right now, sending a positive. Negative, positive. It's easy as that. It's just toggling between these two. Back and forth, back and forth, back and forth. It's a very sweet circuit. It's even more sweet when it's soldered together. This is one of those circuits that doesn't really function quite well in breadboard form because the two transistors are always going to be a little sketchy in breadboard. So they become a lot more stable in a soldered position. But essentially that's the circuit. Okay, so now we're going to do reverse engineer this circuit to a schematic. Okay, I feel that that would be a good evolution. And then for an assignment, you should take and reverse engineer that over back to a breadboard. Or you can follow this video. But I would not cheat and go back. You could if you need some pointers. But what I would do is once we take it and put it over to a schematic, I would then practice taking the schematic over to the breadboard based upon what memory you have and what knowledge that you have occurred of how things work. And if you need a pointer, no big deal. You can just go all the way back and look at how I built this for you right in front of you. Alright, let's go. We're going to translate this over to a schematic. Starting with our friend, the Stoic Cyclops. Good little breath here. Okay, so let's just start out with a little kind of like invisible box just to keep us grounded. Okay. Now, we can draw transistors both ways. In other words, I could draw a transistor like this or like this. Doesn't matter. Okay? What matters is this little arrow. So these are both NPN transistors. Oops. Little lines. Alright, just keep that in mind as we're drawing. Also, I'm going to introduce one more character. If we get stuck in our mousetrap, let's say there's an infinite no way to get out of our mousetrap, we always have this symbol. This is our get out of jail free card. This is called ground. Okay? Let's say if I can't get to the outside of the box in our mousetrap, we can always put a ground in there. I don't like doing it, but we will do it. There's another fault. We can go VCC. Okay? Like that. And that stands for positive. So this is negative, this is positive. So if you're ever in a jam, you can use these. I hate using these though. I really do. I like the mouse trap. It looks more. It looks nicer. It just does. But in the program, we use Easy EDA to recalibrate this back to a working circuit so that it can be made into a board file. We do use VCC and ground. It's just I like the look of the mousetrap. I'm picky, so. All right, so let's start with. I always start with the most irritating thing first. That's the Mofset P channel. So we're gonna draw this clear over here. And this class has definitely given me some practice again from when I was a kid. When I was a kid, I could, yeah, you don't even know. I won't get into my satellite TV years. All the good times. Just gonna keep my mouth shut. Boom. Mofset. Drawn. Okay. Boom. Notice this Mofset always acts as kind of like the outside edge of things too. So that's another way to look at it. So we know this is going to be positive. I'm just going to put a little positive thing here. And I'm going to... Don't want to get too tied into it. Do have an eraser stick now. Ooh, high tech. We're just going to go up with this. This is probably one I'll have to draw a couple times to get it to look nice. What else? Well, it's easy. We got the resistor. So, boom, 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 boom. Resistor. And it is flowing into the positive side of my LED. Boom. Boom. Light rays. Okay. We're getting there. So that was easy. Now I got this. This is where it all goes south. Alright, so let's look at this transistor over here for a second. And what we got is a positive transistor, or a positive resistor, hooked up to gate, wait, no, not gate, collector. So it's hooked up to our collector. So it's hooked to positive first, you notice that. Okay, so let's handle that. We got a resistor. That is dangling from positive. I always kind of put these little dots in here. This is 100 K resistor. Notice that all of these gates, this gate's facing, all the connections are facing this way, right? This gate right here is facing this way. It's facing this way over here. It's facing this way over here. So we're going to draw, because of that, this is just based upon experience, I'm going to draw my transistor in this direction this time. I knew that was going to be a problem. Okay, and our collector is hooked up to this resistor. This is what I don't like. I don't like doing this. I don't like doing that. Okay, so in my next drawing variation, I'll bring this down just a little bit. So I'll go through a couple renditions. This is my first rendition. What's the emitter doing? Okay, the emitter is just hooked up ground. Sweet, that's easy. It's a long way down here, so I'm just going to kind of sketch that. I'll just put a negative here for right now, knowing that it's going to go somewhere down to the ground. Okay. Gate. So our gate is hooked up to the collector. Okay, and it's hooked up before the resistor, so it jumps right here. Here's the gate, but it goes to the resistor first. Okay, that's pretty easy. We just go up. Just like that. Yeah, this is going to get hairy. This is going to be amazingly hairy. Okay, I'm going to hop down here. Gonna hop down here. Let's start looking at this transistor now. Okay, same thing. Draw another transistor here. Like that. And what we got hooked up to this transistor? We got capacitors, we got a collector, we got the emitter being hooked up to the negative. Yes, easy. Easy. Just drag that down there. Okay, we got a resistor hooking up to the collector, and it's in the positive. So it's hooked directly to positive to the collector. Is there any way to get to the positive? Is there any way to get to the positive? This collector needs to get up to the collector. Get up here. So there's not going to be one. We could cross the streams. What that means is, see how these dots exist? We could make one that goes like this with no dot. That's confusing to people. I don't like schematics that do that. So rather than do that, let's look at it. We do have it hooked up to a switch too. See it? So it's being hooked up to the switch. So let's start it there, and we'll worry about that resistor here in a minute. Boom. Okay, we got a switch, and the switch is now open. Let's draw the other side of the switch. Boom. So there is a resistor that hooks up to the switch that goes to the drain. Luckily, the drain is right here, so that's convenient. That's good. What else is hooked up to this side? Well, we got the gate. The gate on this guy is hooked up to that side of the switch. Do, 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 do. What about the gate here on this side? Well, that gate is hooked up to the other gate. I'll put a connection here just to make sure that you know that. First rendition, so alright, so this side of the switch, what else is it hooked to? So we got everything but this resistor in place. This little dude that is coming off the switch, off the collector, and into positive. Again, we can't get over to positive from here. So this is where things cross streams. Okay, so what we do is we take this one and we go boom, boom, boom. Okay, that represents now ground. So that means it's hooked all the way down here. And then we take this one and go like this. That's our 100K. Boom. We now have all of this except for the cap. Okay? But I see it. I see the cap. So the cap is coming off of this. Okay, it's positive here. Then it's negative here. Get rid of the symbol in the center because it's confusing. And then boom, 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 boom. So if you're all in any doubt, so we count up our resistors. We got 1, 2, 3 resistors. We got 1, 2, 3 resistors. We have this one. This one's the 1000K to protect the LED. Okay, we have the 5210. We have the gate, drain, source. This one's symbolizing ground. So over on this side of the switch we have 1, 2, 3 connections, okay? On this side of the switch we have 1, 2, oh, no, and this is this side of the switch. So this side of the switch is this side of the switch. So this side of the switch we have a resistor, check. Okay, we have a gate, check. Okay, and we have another gate, check. Okay. Now on this side of the switch, we have a collector, check. We have a capacitor, check. And we have a resistor, check. This should be a video game. So there's rendition 1. So now I would take rendition 1. You got both. You got this one just in case. You got this one. I would even draw a new rendition if you want for your own notes. But this is where you would reverse engineer or take this one over to breadboard using all of this and get it to work. Oh, I bumped something again. Darn it. It is a flaky little... I do not like this breadboard. See, look at that. It's wiggly. It's an okay breadboard, but if you ever had a SparkFun breadboard, they are really tight. They're really expensive though, so there we go. Well, I hope you enjoyed the very long Mofset toggle tutorial. Enjoy.